Good afternoon. Good afternoon, ladies and gentlemen. I hope you can hear me okay. So my name is Jacques-Étienne Grandjean. I'm the Sales and Marketing Director for SYSNAV. SYSNAV is a French company based in Normandy, in Vernon. And we're a fairly young and small company specialized in geolocation solution in GPS denied condition. So the purpose of the solution I'm going to talk about today is to geolocate first responders and dismounted soldiers in GPS denied conditions. As I mentioned, we're a company specialized in providing precise 3D geolocation in GPS denied environment. Our solution can either geolocate vehicles or geolocate soldiers and first responders. The core technology of the company is really called magneto-inertial technology. It comes from the military environment, from the expertise around inertial solution. Inertial electronics is about using accelerometers and gyroscopes to compute a trajectory. This is a kind of equipment you can find on a battle aircraft or on a submarine, and without any GPS, just by using the acceleration and the gyration, and you can compute the entire trajectory of the vessel. So we have a very strong expertise in that area, but we've expanded the solution by adding magnetic sensors, magnetometers, and we use those magnetometers to do some computation around the speed in the magnetic field. And by combining this information around the speed in the magnetic field with the other information coming from the other sensors, we can increase the precision of the calculation and of the dead reckoning, which is the calculation of the trajectory with no other elements. Obviously, we can use GPS when GPS is available, but there are many situations where GPS is not available, either because you're in a battlefield, and in the battlefield, the GPS signal is jammed or spoofed, or obviously when you are inside a building, when you're indoor, obviously there will be no GPS available. So the expertise of the company is not only this expertise in the core magneto-inertial technology, but we do all the hardware design, electronics design, the manufacturing of the products. We do very precise sensor calibration. We develop all the embedded software. We also have large project management capabilities. So this is the full spectrum of the expertise in the company. We have a number of solutions. Some of those solutions are around vehicle geolocation, and some other solutions are around personnel geolocation, and this is what I'm going to focus on right now. So geolocating personnel inside a building is not an easy task when you don't have GPS. The challenge is doing real-time geolocation in 3 dimensions in GPS denied environments, so inside buildings or underground structures, and sending alerts when you have a man-down situation. So when a man is falling down because he's wounded or there's an accident, the ability to trigger an alert and send that alert. Obviously, when it's either firefighters, first responders, or dismounted soldiers, usually you don't know the structure of the building. So there's no way you can deploy an infrastructure beforehand. There's no way you can equip the building with some positioning infrastructure. So the name of the game is really to find a technique to geolocate personnel without having to pre-deploy any infrastructure. You cannot deploy Bluetooth beacons, you cannot deploy ultra-wideband beacons. That's something you may want to do in some industrial environment when you have time, but in emergency situation, there's no way you can do it. In most cases, you know, in a battle zone, inside in an urban area, you won't know the inside structure of the building. So what SYSNAV has developed is a solution with a small electronic device, a small sensor that is matchbox size. I have one in my pocket here. I can show you. This is the device, and it's fairly light, and typically you will carry this device on your leg. I will show that in a minute. The device embeds a number of accelerometers, gyroscopes, magnetometers, barometer, thermometer, obviously the processing power, and embeds our software with a calibration algorithm and the 3D trajectory reconstruction algorithm. With that kind of equipment, we can compute the trajectory with fairly good precision. There's a little bit of drift because the sensors are not 100% perfect. The drift you would typically experience is about 1% of the travel distance. So if you walk 100 meters, maybe in the end you will have a 1 meter uncertainty in terms of your location. But still, you know, 1% precision is pretty good. So the way it works is the device is paired to a smartphone via Bluetooth. That's our current prototype system. And most of the computation, the 3D computation, takes place on the device. But then the data is sent to the smartphone. The smartphone can do some display on the map. If you have the map of the building, if you don't have the map of the building, you can use satellite imagery instead, as an example, and plot your position with the elevation on top of the satellite imagery. If you have the internal structure of the building and the digital map of the building, we can use that digital map for display purposes, and we can detect your elevation, so we can display the right floor with certainty and position you on the right floor. We can even do more than that. In some cases, when we have a precise digital map of the building, we can leverage the digital map to correct the drift and correct the trajectory. If you use a corridor as an example, we know that you're not going to go through the wall, so if there was a small drift with a trajectory, we can reposition and correct the trajectory at the right place in the corridor or in a doorway. The position is then sent by the smartphone to a cloud, to the cloud, or via a 4G link to a server, and then it can be visualized remotely by the command center or operations center, or we can send the position into a C3 ISR or C4 ISR, C5 ISR system for supervision purposes, and you can supervise as many operators as you want in real time and visualize their position and their tracks. We can store the trajectories, we can replay the trajectories, so also for training purposes, it can be fairly useful to use that kind of solution. So let me now roll a short video which will show how the device is operated. You install the device, power up the smartphone, and you can see on the smartphone the position, but then on the right-hand side you see the web application accessing the server, and you can see the position of our colleague with a few seconds latency. When our colleague goes down the stairs, you will see the floor change from the first floor to the ground floor automatically, and you can see the precision is quite good. This is another experiment that we did with the French Army at a training center of the French Army, urban warfare training facility. And you can see we went in the building, move up several stairs, we go down several stairs, we walk around many rooms, and we keep a very good position with no GPS and no pre-deployed infrastructure at all. Just by capturing the movement and reconstructing the 3D trajectory. So we are participating in the Centurion project with the French Army, with Direction Générale de l'Armement, and we are developing two versions of the solution. One version for dismounted soldiers for the army, and one version for firefighters. And I have a strong collaboration with the Paris Fire Brigade, where we do monthly experiments jointly with the Paris Fire Brigade, and we also have other engagements with fire brigades, not only in France but in Monaco, in the Far East, in the Middle East, and in the US around this solution, which is gaining a lot of attention right now, because indoor geolocation of personnel is I would say a key challenge. And we're just one of the few companies to be able to tackle that challenge. So this is it for my presentation. We have a booth there in Hall 6, not very far from here, 6FE 500. So don't hesitate to come and visit us if you have more questions, or if you have a few questions right now, I'm happy to answer your questions. Et en français si vous voulez.
I have a question. Thanks for the presentation. In this kind of it's inertial based, right, approach. There is a need, at least this is how I see it, for initial position. How do you acquire the initial position?
Okay. So good question. The question is how we can reconstruct the trajectory, but we need to know the starting point and starting direction. So the way we do this is in the HMI, in the app. You can very easily point the location where you are and indicate the starting direction. And this is done through the smartphone app. That's one way to do it. There are other ways to do it. We can, in some cases, use beacons, like ultra-wideband beacons or Bluetooth beacons to determine the initial position. We are even working on automated solution where we would put beacons on the vehicle, and when personnel dismounts from the vehicle, either firefighters or soldiers, they would be automatically initiated, both in position and in direction. Any other questions? All right. Yep. Maybe one question. Yeah.
What if your cell phone, you had the cell phone also, what if the cell phone has no connection?
Yeah, good question. I can go back to the diagram. So if the cell phone has no connection, we can store the position for all the time where the smartphone loses the 4G connectivity, and we buffer all the information, and when we recover the connectivity, we send all the position at that time. We can also use alternative communication means. We can use Wi-Fi, we can use 4G. We're working on LoRa mesh, and other type of network technology, so that the smartphone has a number of options, and always find a way to transmit the information. Sorry, can't hear your question.
If you have zero connectivity, so let's say you lose connectivity at time X, okay?
If I lose connectivity?
At time t equals 0.
Uh-huh.
And you have no connectivity for the next 10 minutes or 20 minutes. How do you know where the person is? If for 20 minutes he may have gone to the third floor, to the ground floor, anywhere.
You're right. There has to be minimum communication. Otherwise, this part can function, and at least the person can know where the person is, But sending the information to the command center is still an issue. So we need some form of communication to send the data. Yeah. So for maybe 30 seconds, 1 minute, we can lose the connection and then send all the historical information back. But if you lose for 20 minutes, that's a problem. Yeah. Sure. Any other question? Okay. Well, thank you very much. Have a good afternoon. Thank you.